Hello students, this is Anjana from Computer Science Department. In the previous classes, we have discussed few topics in combinational logic. So now let us see the remaining topics here. Up to here we have discussed the truth table for 2 to 4 decoder. Up to here we have discussed. Now let us see the combinational circuit for the 2 to 4 decoder. We have taken the AB values here. For the A value and A bar value and B value and B bar value, we have taken the AND gates here, and these are the AND gates. Here A bar, B bar. Next one is A bar, B. You must have the we need to have the four possible combinations. That is Y0, Y1, Y2, Y3. A bar, B bar means 0 0. A bar, B means 0 1. A B bar means 1 0. A B means 1 1. These are the four possible combinations. So for A bar, B bar, we have to take the two not value. So for that we have taken the not gate. From the not gate we have taken the A bar. Here from this not gate we have taken the B bar. So this value will become so these two values are taken as a input, so those two values are 0. So instead of taking any values, we have taken some values, so this one is enabled. So we are having this enable bar. So for each and every AND gate we have connected this enable bar. The first one is Y0, that is A bar, B bar 0 0. So at the 0th position we have to place 1 there. And next one Y1 A bar B, that is 0 1 means 1. So at the first position we have to place the 1 there. And next one is A B bar, that is 1 0, that is the value is 2. So at the second position we have to place the 1 there. And next one is Y3 A B, that is 1 1, that is the value will become 3. So at the third position we have to place the 1 and the remaining values will become 0 there. So this is the combinational circuit for the 2 to 4 decoder. If you have observed, we have taken the one value for A and one negative value, that is one not gate value. You have taken one not gate, and second one is this one normal, and this one also for B also we have taken the not gate. Why? Because instead of taking the non-negative not values, we have taken the not values also. So for that reason we have taken this not gate. Okay, so if you have observed this truth table for the 3 to 8 decoder, so if these three values are null, that is we have not entered these three values, so definitely the enable button will become 0. If you have applied any input, automatically the enable value will becomes 1. So initially the value is 0 0 0. That is the truth table for the 3 to 8 decoder. Initially the value is 0 0 0. So here at the 0th position we have taken the value. At the 0th position we have taken the value. We have placed this value 1, and the rest of the places we have placed the value as 0. Okay, and next one here 0 0 1. 0 0 1 means 1. So at the first position we have placed this value 1, and the rest of the values all become 0. Next one 0 1 0. 0 1 0. So at the fourth place, we have placed the value 1 and the rest of the place we have placed the value. Next one is 101. 101 means the value become 5. So at the fifth place we have placed the value 1, the rest of the values will be 0. Next one is 110. 110 means the value is 6. So at the sixth place we have placed the we have placed the value 1 and the rest of the values will become 0. And next one is 111. 111 means 7. So here the value is 1. At the seventh place we have placed the value 1 and the rest of the places will become 0. If you have observed, we will get 1 like this. Okay. Do you understand why this enabled become 0? Why? Because here we have taken nothing, we have not taken any input, so the enable button will become 0. If you have taken some combinational inputs, then automatically the enable buttons will become 1. Okay, this is the truth table for the 3 to 8 decoder. Okay, go for the next slide. So if you have observed the logical diagram for the 3 to 8 decoder, see, first initially why not, that is the values should become 0, that is a bar, b bar, c bar. So for a bar means we have, for a we have taken this normal value and this is a bar. For a bar we have taken this not gate and this is b, and for b bar we have taken this not gate and this is c, and for c bar we have taken this not gate. So first one is a bar, b bar, c bar, that is initially the value becomes 0 0 0. So this one is a bar, this one is b bar, and this one is c bar. So this is a bar into b bar into c bar, so we have applied this AND gate. Next one is a bar, b bar, c, that is from here we have taken a bar, next we have taken b bar here, next we have taken c here. So this value will become a bar, b bar, c. And next y2, a bar, b, c bar. So here this value is a bar, and next one is this one is b. Here we have not applied any, here this one is not, so this is only b, so we have taken b here. So next one is c naught, so we have taken the c naught value here. Okay, this is enable button. Next one is a bar, bc, that means only we have to take the a naught value and bc remaining values here. Next one, a b bar, c bar, that is we have to take the a normal value here and next we have to take the b bar, c bar values there. Next one, Wi-Fi means Wi-Fi means a b bar c, that is we have to take the a c normal values and next we have to take the b bar as a negative sorry not value. Next one, a b c bar, that is we have to take the a b as a normal values and c bar as a negative value. Next one, a b c, so y7, that is a b c 1 1 1, we have to take the a b c as a normal values. So if you have observed in this diagram, we will having NOT gates and AND gates. So with this we have designed a logic diagram for the 3 to 8 decoder. Okay, then go for the next slide. Then uh, now let us see about the BCD to decimal decoder. BCD decoders have 4 inputs and 10 outputs. Okay, here the 4-bit BCD input is decoded to activate one of the 10 outputs. See, why it has designed for the 4-bit input is to activate one of the 10 outputs. See, we have already discussed that BCD decoders have 4 inputs and 10 outputs. So if you have observed that the 4-bit BCD input is decoded to activate one of the 10 outputs, and it accepts for the 4 active high BCD inputs and provides 10 independent active low outputs. So from this we can say that BCD decoders have 4 inputs and 10 outputs. And next one is the 4-bit BCD input is decoded to activate the one of the 10 outputs. And next one is it accepts 4 active high BCD inputs and provides the 10 independent active low outputs. So this is about BCD to decimal decoder. Okay. Next one. So BCD decoders have okay. Now let us see about this multiplexer. Here a multiplexer is a digital switch and it allows the digital information from the several sources to be routed onto the single output line. So the section of a particular input line is controlled by the set of selection values. Normally there are 2 power n input lines and non-selection lines whose bit combinations determine which input is selected. Suppose if you want to select an input, then definitely it will work for the without any work. Definitely it will be used in the multiplexers also. But here in this multiplexers, it is a multiplexer is always a digital switch. So what it will do, it will allows the digital information from the several sources, whatever the sources that we are having there. From that several sources we are going to allow the digital information, and it is routed to be onto the single output line. So the selection of a particular input line is controlled by a set of selection lines. So from this we can say that it is having the multiple selection lines. So here the selection is a particular input line, and it is controlled by a set of selection lines. So normally there are 2 power n input lines and the n selection lines whose bit combinations determine which input is selected. So how many input lines are there here? 2 power n input lines. And how many selection lines are there here? N selection lines. So first of all, if you compare this 2 power n input lines and n selection lines, we will have some bit combinations, and the bit combinations will determine the input which you are going to select it. So from this we can say that it is a digital switch which allows the digital information from the several sources to be routed onto the single output line. So the selection of a particular several sources to be routed onto a single output line. So the selection of particular input line is controlled by a set of selection lines. So normally there are 2 power n input lines and n selection lines whose bit combination determine which input is selected. So if you have observed that this multiplexer, this is a 4 to 1 line multiplexer. See, here you are having the 4 to 1 multiplexer. Here you are having AND gates, and this is the OR gate. So this is D0, D1, D2, D3. These are the possible combinations here. 0, 0, 0, 1, 1, 0. 1 1. These are the most popular combinations here. But here the another most combination is this is also a block diagram for it. So then we can consider it as a block diagram for the multiplexer. So if you have observed this one, this is the terminal for input terminal, and this one is this was a certain terminal to enable the input. Next one, if it is a 4x1 multiplexer, these are the selected inputs, and that one is the output. So these are the enable inputs here. So that one is a 4x1 multiplexer. This is a 4 to 1 line multiplexer. This is the possible number of inputs, D0, D1, D2, D3, and here we are having the AND gates, and this is the OR gate here. So this is D0, 0, 0, 0, 1, 1, 0 and 1, 1. At 0, 0 we'll place D0, and 0, 1 will place D2, and 1, 0 will place D3, and 1, 0 will place D2. So this is the possible combination that we'll get based upon the number of inputs we have taken. On that the number of inputs we'll get. So here this is the output. Okay. See, if it is a quadruple 2 to 1 line multiplexer, so if this is one quadruple, and this is another quadruple. So if it is a quadruple 2 to 1 line multiplexer, what is the image for that? Let us see once. Here we have taken the 3 NAT gates. First one is to disable these things, these two quadruples, and next one is to enable. Okay. Here the first line we have taken the AND gate, and at the output for the presented output we have taken the OR gate. Okay. And next one, here at A1 also we have taken the AND gate, and for the resultant output we at the end of the Y1 we have taken the OR gate. At the A2 we have taken the AND gate, and at the Y2 we have taken the OR gate. At A3 we have taken the AND gate, and at the Y3 we have taken the OR gate. Just like that, at B0 we have taken the AND gate, and B1 we have taken the OR gate. At B1 we have to take the AND gate, and B3 we have to take the OR gate. And these are the multiple combinations for the woman NJP. So this is the quadruple 2 to 1 line multiplexer. Then go for the next slide. Now let us see how we are going to expand this multiplexers. See, the implementation of the combinational logic using the multiplexers. So a multiplexer consists of a set of AND gates whose outputs are connected to a single OR gate. So here in the previous slide itself I have discussed to you that the inputs are connected with the AND gates and outputs are connected with the OR gate. So because of this construction, many Boolean functions in the sum of the products can be easily realized by the multiplexer. So because of this function itself, the sum of the interstate ఉండే మల్టీప్లెక్సర్స్ని కూడా యూజ్ చేయొచ్చు. సో they can realize that. Next one is so if each AND gate in the multiplex represents the min term. Each so in 8 to 1 multiplexer there are 3 selected inputs and 2 cube min terms. If you are having 3 selected inputs, then it will be, if you are having n selected inputs, then the output will be n, then we are having 2 power n min terms. So if we have 3 selected inputs, then we are having 2 power 3 min terms. So by connecting the function variables directly to the selected inputs, a multiplexer can be made to select the AND gate, and that corresponds to the min term of the function. So if the min term exists in the function, we have to connect and get the data to logic. Otherwise we have to connect the otherwise we have to connect that logic to the 0. Okay. Okay, up to here we can stop. In the next class we will discuss about this demultiplexers.